the previous videos, we mentioned about planning of your research. You know that your research needs to be planned in stages on basis of your objectives, where each objective is supported by a series of testing program, result and analysis, which will later be used for the discussions and conclusions. You will need to optimize your research, minimizing the overlapping and redundancy, so that every single stages of your research plays a significant role in achieving your research objectives. We also mentioned about the data collection plan. On basis of your research design, you will need to have a better idea how the testing programs are being carried out. It is very much dependent on the purpose of different stages of the study, what kind of questions you would like to ask, and how you are going to conduct your study in order to acquire the answers. There will be quite a number of minor aspects which involve considerations of the data, measurements, instruments, samplings, precautions measures, and others. These data collection plans are normally constructed before you actually carry out your study. This needs to be planned as thorough as possible to avoid any hassle or difficulties that you encounter while you're conducting the studies. We also mentioned about planning for the variables. Again, on basis of your research design, you need to know what kind of data that you are looking for, and you need to observe what kind of variables that you intend to study, and there will be manipulated variables, made up of the fixed variables and changing variables, which during your study program, the data and result that you have acquired will be the responding variables and the derived variables. You manipulate the variables so that you are able to observe the parametric response as reflected by the responding variables as well as the derived variables. You need to have an idea of all the variables that you're going to use or encounter throughout your study, so that you can proceed with your research study smoothly. Now let's say we have identified the variables. You need to do the planning for the analysis. There are several questions that you can ask yourself. How do you intend to analyze the data? Your answer may involve the methods, tools, and software that you're going to use. And you might want to know, how do you verify or validate the data? It is for the purpose of the reliability and validity of your data. You might want to know also how you intend to present the data. Are they going to be presented by the tables, graph, pie chart, histogram, or etc.? Each of these data presenting tools has their own unique characteristics and functions. You will need to choose the right one to best reflect the purpose of presenting the data. You might want to ask yourselves also, is the defined sample methods sufficient for you to draw conclusions to answer your research questions? This series of the questions can be considered as a self-evaluations, giving you an idea whether you have a thorough picture regarding your research study before you actually started your study programs. Of course, there are other more questions that you can ask yourself depending on the needs of your research, such as how do you quantify the confidence level of your findings? or results? How do you detect the outliers in terms of your data? In the case that there are some data that you suspect is not reliable, which can affect your results, and so on so forth. You are always encouraged to plan ahead, at least scan a bigger pictures, finding the linkage between different stages of the research throughout your entire research. The more detail you can consider give you better confidence in carrying out your research. Let's say now we take this as an example, going through these typical questions when you are planning for the analysis. For example, how do you intend to analyze the data? Are you going to use the software design experts, or you're going to use statistical software SPSS, or you use the Microsoft Excel? This represents the software that you are using, or there may be other more software which you can use in your research study. Then probably you want to know how do you determine the behavior of the beam. As an extension from our discussion previously, we are looking for the load displacement response. We are looking for the mechanical properties. We are looking for the efficiency ratio. We are looking for the parametric response as well as the failure mode. Now you will try to answer the second questions. How do you verify or validate the data? You may set the requirement for you to confirm your data is reliable. Probably you are looking at the accuracy of plus minus 10%, and you are looking for more than 80% of the specimen with plus minus 10% accuracy. You may need to justify these numbers, as sometimes your examiners or supervisor might query on that. Why do you put 80% and 10% instead of 90% or 95% and plus minus 5%? And you need to aware that sometimes if you put those values very high, that means your validation process might not be achievable, particularly due to the limitations of certain analytical models, which are oversimplified by a series of the assumptions. Sometimes it could be due to the limitations that it is nearly unable to achieve with limited numbers of the parameters considered to the extremely high requirement in terms of the reliability and validities. This will be very much dependent on the level of understanding that the entire research community towards a particular topic. And you should aware that sometimes you should not put this requirement too low, which defeat the purpose of doing the verifications or validations of your analytical model. Let's say now you set it the accuracy requirements of plus minus 25%, and you need at least 50% of the specimen within that plus minus 25%. The requirement is rather low. Based on that validations requirement, it will be as if not validated. You have to be careful with that also. Personally, based on my personal experience, for most engineering applications, this 80% of the specimen with the accuracy of plus minus 10% is considered good enough, having a certain levels of requirement which is achievable. You know that the so-called plus minus 10%, that one is equivalent to 20% variations. If you are talking about the minimum value and the maximum value within the range. And 80% here, it will be quite okay for you. as it represents a significant majority. Sometimes you may find it very hard to achieve that. You might want to tune it slightly lower. For example, 75% of the specimen within plus minus 10%. The idea here is should at least represent a good majority among the specimens when you are doing the validations. And in terms of the validations, you might want to identify the scope of the validations, which in this case, the validations concentrate on the strength property, which are the yield strength and the ultimate capacity. And also there will be validations in terms of the failure mode. Of course, the more aspect that you can do the validations, it gives you a higher confidence level in terms of the reliability and accuracy of the model that you have developed in representing the actual situations. As for the scope that you use to validate, it should be of the significant response of that particular specimens. Focus on the key parameters instead of those that are insignificant. As for how do you intend to present the data, in this case, there will be graph and tables. And you need to review your entire research planning from the flowchart, from the data collection planning, from the planning of the variables, and from the planning of the analysis. You want to know whether your entire research program is it sufficient for you to draw good conclusions to answer your research questions. If you found the answer is no, that means you have to go back and review your planning in terms of the research methodology. This process should continuously loop until you are satisfied, knowing that all the objectives can be answered through your entire research program. The term here is about all the objectives answered. Sometimes you may encounter a situation that your hypothesis before you carry out the research cannot be proven, or more specifically, you have an hypothesis and it is proven wrong. In this case, your objective is still considered answered, only that the answer come out contradict to what you hypothesized. It doesn't mean that a good research must have a successful product or prototype, or when you encounter your result demonstrating certain theories is not workable, it doesn't mean that you fail your research. It only means that the prior understanding or hypothesis is not entirely true. As when we evaluate the research, we are looking into the depth of the study. Even though your hypothesis is proven wrong, you will have to report it honestly. Never go and edit your data so that it yields you a favorable outcome, as this is a violation in terms of the ethical conducts. And editing those data, it will give the reader wrong informations and mislead the readers towards the wrong directions and misunderstanding of the research topic. This shouldn't be done. What you are supposed to do here is to dig deeper, looking into various aspects, finding the causes that leads to proving your hypothesis is wrong. You should position yourself actually finding the answer. The answer is that you know a certain hypothesis or a certain proposal or a certain design is not workable, and then your discussion shouldn't stop there. There will be further discussions. Why is it so? Why the hypothesis is proven wrong? What are the factors? Any ways to rectify this? or any recommendations to improve the results, and so on and so forth. Under these circumstances, your objective is still considered answered, only that the outcome proves that your proposed design or your hypothesis as formulated from your literature review have some limitations or totally cannot be used. Reporting this honestly will help the future researcher to avoid similar mistakes and will guide the readers towards better considerations when they are designing for certain things.